The next talk is called Leveraging Quantum Computing Applications for Companies of All Sizes. And we have two speakers again. The first speaker is Tim Leonhardt. Tim Leonhardt actually holds multiple master degrees in physics as well as in economics, business, and management. He has 5 years of experience in semiconductor quantum computing research, and since 2018 he is responsible at Accenture for quantum computing innovation projects. Our second speaker is David Niehaus. He interestingly also holds 2 master's degrees, one in industrial engineering and one in aerospace management. So he's the head of product at Stone One's quantum product unit Anacor and community manager for the research project PlanQ, which is also the project that both of our speakers are going to talk about now. So welcome, Tim. Welcome, David. We're looking forward to your talk. The stage is yours.
Thank you so much for the introduction. It's a pleasure to be here. And after we've just heard the talk on quantum software engineering, I think it's very fitting that we now continue. You may hear other speakers also speak about PlanQ because we have lots of interesting use cases, and I'm very happy that we're present in such numbers. So welcome to our talk, Leveraging Quantum Computing Applications for Companies of All Sizes. What we would like to give you here is a very quick introduction to the research project PlanQ, which is being funded by the German government, particularly by the Ministry for Economic Affairs. And after introducing the project itself, where we show how we want to integrate the different stakeholders of the quantum ecosystem, which is also a major topic, of course, here on this conference, we'll want to show you a little bit of the methodology that was developed in the project to identify potential use cases. And Tim was happy to present one of from Accenture, one of the use cases more in detail. So without further ado, I'd like to start by going a little bit into the detail of what is PlanQ. Well, first of all, of course, it's named after Max Planck, but it stands for Platform and Ecosystem for Quantum Assisted Artificial Intelligence. And now you know why we call it PlanQ, because it's such a long name, but it's a great name. And the vision behind it is also great. What we intend to bring together here is the primary stakeholders of the quantum application lifecycle. We have in Germany, but all over the world, companies that want to use quantum computing, that want to use respective applications to solve their individual needs. They can be large corporations, but they can also be small, medium-sized companies that do not necessarily have the budget to invest in research and development, but they still have potential use for quantum computing. We have solution partners. We have developers that are, for example, using new methods to program quantum circuits, but we also have consultants that need to advise those users that we spoke about earlier about their specific needs, whether quantum computing is actually something that can solve their problem. Then we have experts that further our understanding of quantum algorithms, that provide open source software. And last but not least, we have, of course, the providers. We can write the greatest code, doesn't bring us if we can't actually run it on one of these great new machines. So this is the fourth and final stakeholder that we want to bring together within PlanQ. I'm going to come to who that we is in just a minute. But prior to that, I want to show you a little bit of what is PlanQ actually about. Now, I said it's a platform. We consider it an open ecosystem, a platform of platforms with many different features planned. Those features are intended to serve each of those individual stakeholder groups. So what we currently have in closed beta, and just to answer that question, which will probably come right away, yes, we are planning to grant public access to PlanQ, hopefully by the end of this year. It's not something that is intended only for the initial PlanQ partners. So right now it's a knowledge platform to provide curated algorithm information, which is coming from academic and industrial experts, provides develop those information items, and to also provide associated implementations. They can be downloaded, and in the future they can also be executed through the platform to run on different hardware configurations. And that also brings us to those future features. Right, with this knowledge platform right now, we are particularly serving the areas of the solution partners and the experts, right? They know how to use this stuff. But in order to also enable companies that do not necessarily have that expert knowledge in their workforce, they will be able to participate to buy that knowledge, to gain that access through the marketplace by either issuing a call for a specific application that they need or general applications. For that collaboration, we're also building a GDPR compliant data room so that secure data exchange can happen. Also, again, a feature which would connect both the user side as well as the solution partner side. And then for developers, we're particularly looking for enablers through our NISC analyzer and workflows, two future features that will enable the better use of quantum computers through already existing software development ideas. And through those functions, we hope to enable all the different stakeholders that I initially presented. Now, I've mentioned we, and let me just give you a brief introduction. So Planck is a consortium. As I said, we're a research project. The consortium partners, you can see them here on the left-hand side of the slide. It's 19 different companies and institutions, academic institutions from Fraunhofer to University of Stuttgart, which holds the scientific directorship. And then, of course, from large multinational companies such as Tim's Accenture, down to small but exciting German startup companies such as HQS, which is also, of course, present in this conference here. I myself am with Storm 1, which is also featured there. Now, we have these 19 consortium partners, but we also have received such a wide interest that we have opened up our associated partner side. So anybody who's interested in Planck is more than welcome to join us. We want to bring that knowledge out there. And those associated partners can be seen here. As you can see, all those four stakeholder groups that I introduced earlier are represented. We have the quantum computing resource providers, we have solution partners, we have experts, and we also have potential users. One of the things that we wanted to work on when we started thinking about the vision of Planck was we do not only want to have this platform, but we want to have a proven ecosystem. So what does that mean? It means we have to demonstrate it with use cases. And so all the different partners brought together use cases from their individual needs, either from their clients or that they face themselves in their business. And here you can see actually the selection. We have more than 30 use cases. And what we're doing within this research project is that we are ascertaining whether quantum computing, first of all, can generate a benefit within this specific realm. But then also, how can it be deployed via the platform? And this would then also serve to enable not only the partners itself, but also lead to a more lighthouse character of the project and understanding where all these different applications can be found for quantum computing. And one of those specific use cases, I'd like to hand over to Tim now. To show us a little bit the methodology that we developed within the project and that we would like to publish here to get access to. Tim.
Thank you very much, David, for this great introduction to Planck, and I'm happy to share with you a little bit the experience that we already made within the consortium, what we've learned, especially in looking into all these proposals that came to us with these use cases, and the experience that we made in the first 1.5 years to have an early assessment of these use cases and making sure that we are not only addressing, let's say, the business interest and the use cases that our partners find relevant, but also get a better understanding of what can be implemented and realized on quantum computers, supporting decisions. What is actually a good reference use case that can be implemented, and how far is the technology, and the methodology that we've come up with in this consortium that many consortium partners used in detail, that created in the end detailed requirements analysis and descriptions, concepts of how they approach and now implement these use cases. I want to share with you now. The first side, and this is something where we try to start the connection, is always the question of what is actually the value that is should be generated by the solution. Yeah, so it's not that we in the end want to use the technology just because it's fun, but in the end really want to understand where could it create some additional value for a user. Yeah, so can we reduce costs, or can we maybe improve customer experiences? And we have collected a couple of guiding questions that I won't go into detail, but that helped us to sharpen the propositions, also maybe gain support, financial support when it was a very relevant use case, and then go to the next step of really discussing what is actually what could be some business problems when that, or some problems that occur in the transformation and assessment of the and implementation of the project. And a couple of questions that we discussed there is actually can we even now that we know that there's a business need, can we discuss with the future users or with the current colleagues that approach this problem? Can we exchange with them what quantum computing is, how quantum computing works, and develop an idea where it could actually a technical advantage is needed? Other topics and questions are, and this is something that David already addressed, questions of GDPR compliance, the question, do we have even access to the data? Can we use it? Does it maybe have the sufficient quality? Yeah, so there are several regulatory issues that I think many incubation units would love to overcome. Yeah, and I think Planck is a very good platform to share data and make sure that we have a similar platform like I don't know, Kaggle or others, that help us to really get quickly into the terms that we want to use, which is the technical solution. Yeah, and the last part of this, let's say, overview and business canvas that you create to early assess these use cases. On the quantum solution side, you already see a couple of guiding questions that we discussed in the beginning. Can we access the data? Do we have like a mathematical formal description of the problem and some solution approach? Also, what should be the output? But with this, I think I'll share on the next slide a more updated version. And this is actually something that we have published with colleagues from Accenture, where we build on this experience and other experiences to go from an early identification long list, very long list of use cases that could be relevant to business, to a shorter use case short list that is more likely to be realistically implemented on a quantum computer. Because I mean, we are all aware each of these use cases takes resources and ideas, and it would be good to identify early on what could run and what the expectations are that could be it on a solution, and that we expect on a running quantum computer in a few years, or maybe, and this is I think very interesting, on the basis that we've learned to build a new model or use new algorithms, maybe improve the classical algorithms that we used with the knowledge that we have from quantum algorithm research. And the main steps that we have identified, and this is not a strict stepwise approach, but these are like fields that we can look into, is at the first stage always to really discuss how to model this as a computational problem. Yeah, so currently you definitely need some mathematical rigor to really understand how can I translate my business problem into a mathematical description. And this is something I think where Planck and service providers like us can help, is to really say, is this a problem that we can formulate in a mathematical description? And is this even a problem that we can also formulate in the quantum computing description? Yeah, so this is the first checkpoint to make sure that we can really, let's say, go to the quantum realm with this problem. The next question is what we call the complexity sieve. So there's always a theoretical approach on whether this model that you have come up with is trivial. Yeah? So for example, we won't use quantum computers for improving addition or multiplication of numbers. Yeah? So it isn't a sensible quantum approach if it's already readily solved. And on the other hand, there are still problems that quantum computers can't solve. So we very likely won't solve the very big data problems because the input to a quantum machine is rather thin, and there are other topics where it's unlikely that quantum, or even proven that quantum computers cannot help. So really differentiating between the hype and the problems that are sensibly implemented and could be theoretically solvable is an important exercise, and their universities develop theories and help us to pinpoint where quantum advantage could happen for industry. The next question is always looking at the algorithms. How can we? Is it not only in principle possible, but are there actually algorithms or descriptions of how to solve these problems? Be it by an approximation or other topics. And then the next question, and this is something that doesn't get that much attention, is actually that you also would need an implementation and, let's say, software. And there's always the challenge that at some points the algorithms are theoretically described but need an actual implementation that is efficient. And either you have the researcher resources to come up with this by yourself, or it makes a lot of sense to get help, and to check if these implementations are actually ready. And I think the repository that PlanQ is building is helping a lot there. Yeah, so if you have done these steps, you can actually look into the details. And if you want to read more, look for the Digitale Welt that is published by LMU and Professor Linhoff Poppin to get more details. And the last 2 minutes that we have, I want to use to quickly go through an idea and an example that is broadly known to give you an idea of how this can be approached. So this use case example is actually the risk analysis, where a bank typically hands out credits. And of course, they want to make sure that if they have several defaults that can happen, that their reserves are big enough, and they are at some point limited to hand out more credit because the risk would be just too big. And the big challenge is even if you've gotten all the input values, like the exposure that you have, so how many credits do you have given out? You have also the properties of your obligor, so you know what is the rough probability of each of them to fall out. Maybe you also have information that they're interdependent. So for example, if people are living close to each other or are, let's say, somehow related commercially, it's likely that they default at the same time. So you have already good description of the overall network. The biggest challenge is still to let's say, to put a number on, if you're looking at the 10% worst cases, what is the outcome that you can expect? And for this, you typically you formulate many scenarios, you calculate expectation values, you average over them. And the big challenge is that when you're getting more and more of these scenarios, is to efficiently evaluate them. And if you look at this now from a perspective to optimize how you hand out credits, it's even an NP-hard problem to decide how to perfectly distribute this. So there are actually models today that can approximate these outcomes and these assessments, and they scale with 1/n. So the more samples you take of these scenarios, the better your approximation becomes, but there's still some uncertainty. Now, the idea is that quantum computing can actually improve this, but there's still discussions on whether these speedups can be gained on a error-corrected quantum computer. And I think there's still many open questions, and with this, I think I'll leave it to the discussions.
Thank you very much. And we hope you learned something. We're open for your questions. And I think Oliver Horschke is already standing in line to also present the PlanQ use case.
Exactly. Thank you so much, Tim and David, for this very nice introduction to the PlanQ project. When we arranged this program, we intentionally placed the more use cases, the real use cases, and the overview of use cases. At the end, it's very nice to see this working out with the presentations now. Thank you so much once again for your presentation.